Today I'm sitting here with Ulf Aslak. Welcome.
Thank you.
We're calling in from beautiful Italy, where we're on our labs retreat. I'd like to start by just getting to know you and your origin story. How did you get to where you are?
Yeah, so first I was born. I'm from Denmark, and I went to university like so many other people, studied physics. Physics is awesome and interesting, but I've always been like, when I was a kid, I would always like build tree houses and like break things apart to see what was inside and stuff like that. And like physics was very theoretical for me. So like already after a few years, I knew that I wanted to go in the direction of something more hands-on. So I got into coding, programming. Like I think like many other people, you know, when I first like tried running some code and it worked and it like did something for me that would have otherwise required like writing down some math and like staring at it for 6 hours until I could convince myself that it was right. I got this like crazy dopamine rush, and I've just been hooked ever since. So after physics, I did a master's in machine learning and numerical methods for building models, optimization, all these different things, and then a PhD in complex systems. Yeah.
And yeah, what I hear is you're a scientist at heart that likes to take things apart, but also you're a builder, right?
Yes.
And one of the things how I got to know you was through the work you did on the Discourse forum, where you published like a LLM, a ChatGPT, I think that was like trained on PyMC, the documentation, everything to like be an assistant. I was like, that's really cool. And we got to chatting and ultimately work at labs. But then how did those things basically conspire to then finding Bayesian statistics and finding that to be a useful tool?
Yeah. That's a very good question. Like, you're completely right. And I also very much see myself as a builder type person. Like, when I have a problem, like it itches, and I just want to like build something that solves it and like preferably at scale. That was like the reason for this custom GPT thing. It's like, can I just ask ChatGPT these PyMC questions? I get PyMC 3 answers. That's so annoying. Like, okay, let's build a custom one which has all the docs. And I think that was also very much my way into Bayesian methods, because after I quit academia after my first postdoc, and I wanted to go and like solve real problems in the real world. Like I kind of got tired of just writing papers. Like I didn't really feel that it was like proper problem solving in a way. Although of course it can be, but it got very academic. I ended up in marketing, and in marketing, like you have these pretty concrete problems. Like you're just spending loads of money on like different marketing channels, and you don't really know what works. But you have this, money trace. Like, where are you spending your money? Like, how much money are you making from sales over time? And so I was initially trying to solve that problem with like simple regression methods, and just immediately could see that that's totally unfeasible. Meanwhile, I had all these marketing folks around me that had strong opinions about like the performance of different channels, and then just like an epiphany, all my memories of the Bayesian courses I had taken during my studies came back, and I was like, priors, updating beliefs, and then that's sort of like how I got into Bayes. So it was very much like a construction problem. Like we have to build this model, and we have to take into account all of these beliefs and all of these also experimental knowledge that have been gathered over years of working out what works for different clients and what doesn't work and so on. The Bayesian method was just like awesome. It was like, yes, this is the thing. Like this is the framework. Here's the toolbox, and then we could continue building. So that's totally how I got into Bayesian methods, because that was like the tool for the problem.
Yeah, and it sounds like the valuable thing you found, which I totally agree with, is being able to combine different sources of information, domain knowledge, build that custom model, bring that together with data. And I'm curious how like your own background informed that, and when solving problems, for example, with PyMC Labs clients, what do you feel is your unique perspective, given like your training and I guess coming to PyMC fairly late, but then finding it to be a really useful tool compared to, well, not compared to, but next to a lot of other tools for other purposes.
Yeah. So I mean, yeah, I'm definitely not like loyal to any framework or any like specific way of solving problems, and I think that is it can maybe be problematic. But I think overall, I think it's I think that's sort of like maybe my unique skill is that whenever I see a problem, I try not to think like, oh, this is exactly like that other thing, and then you just apply this toolbox, and then you get this answer, and then you hand it over. Like I think there's many ways that can go wrong. What I usually try to do is because I've seen so many different problems and I've seen so many different data sets, and like, you know, if you look at my Google Scholar, it's like all over the place. It's like ecology and like physics and software, you know, it's like all sorts of weird things. I just try to think like, okay, what is actually the thing that needs to get solved here? Like, what is actually the deliverable that the client needs in order to create value in their business? And how do we get at that thing? So what is the sort of, I try to think of like, what are the sort of physical units we're operating with here, and how do we piece them together in order to make this other physical unit which creates value? And I think people call it like maybe first principles thinking or whatever, but I think the core of it is just being sort of like framework agnostic and sort of humble about the problem you approach, because you truly need to understand like what is it that creates value, what are these things actually, and before you just like, you know, burst open the doors with your mathematical framework and just put everything in an equation and it's solved. Like, you know, that can be fast and efficient, and it can also be wrong. So I really like to think of things in terms of what do we have here, like how do we solve this at the lowest level.
And next, I'm curious, since well, the project you joined is like pretty large scale and with like very high velocity, where we're just like really working in depth, but also with a lot of deliverables. Is there anything that you found surprising or learned since starting with labs that maybe like, I don't know, is like totally different, or maybe like surprisingly similar to your academic work, the open source work?
Yeah. So it's funny because when I was in academia, you know, when you're deep in something, it's very hard to imagine a world outside. So when I was in academia, I imagined that like, well, I suppose this is what everyone does, right? I suppose everyone, you know, they solve these hard problems and they go really deep into something and they understand things at a very fundamental level, and then they emerge with like a new theory and some. But then when I was like in industry for a few years, I realized that's actually not how everyone does it. Like, it's especially in industry when there's like this pressure and this velocity, oftentimes like you can deliver a solution which doesn't actually, which was created not through a process of deep thinking and fundamental understanding, but just applying this thing and here's the result. And that was upsetting to me. My first experiences with this type of working was I did not like that. But I think coming to labs was sort of like, in a way, coming home to this like academic way of approaching problems, where like, well, we've got to understand how it works, otherwise we can't solve it. And, you know, like a lot of the people at labs are actual academics, like still furthering their careers and publishing papers. And so this like culture of having to understand the thing really well before we move ahead is very much alive at labs. But then there's also, you know, delivering projects to actual clients in industry and having to do that at a higher pace than what I'm used to. That can be hard, but it also, when it works like really well. And so I think, you know, for me it has been like very rewarding, because I love building things, I love creating value. and I love understanding things at a deep level, and we've been able to combine this in our work, and it has worked really well. So I think that's what I really like about labs. Yeah.
And what really resonates with me from what you're saying is that also I think of us mainly as like scientists, and most of us actually are like trained scientists that then move to business, but I definitely think there is a place for like this type of still like deep thinking and really understanding something foundational. There's like nothing wrong with like more superficial work and just like, I don't know, building very simple analyses. That's cool, and maybe that's where we start, but I think our unique value is really in like going deep and understanding and then like building a solution for extremely difficult problems that you probably couldn't have done to that extent by taking shortcuts or something. But you're right that like that type of like science mentality where usually, I don't know, from like inception to an idea to like a published paper is years, right? Like research programs take time. To sort of combine that with the more high-paced, delivery-based world that we live in. And yeah, it's been definitely an interesting challenge to try and bring those two together. Is there anything that like you find we, I don't know, do well or like can improve on?
Nothing can be improved. It's perfect. Of course we can improve. But at the same time, I mean, we're a small organization, so we can also do things that don't scale, but solve the problem right away, and it's not like a fundamental problem to the way we operate. I think the harder question is like, what do we do as we scale? Like, how do we solve that? How do we remain, small and agile? Like, coming a little bit back to this, like academic solving industry problems and how that's great. Like, we don't have to write papers. We just solve the problem and deliver it. Of course, then we have to maybe give it implementation, maybe think about deployment, but it takes longer to write a paper. It's easier to do deployment. And so that's part of why we can move so fast. And I think the challenge is to continue to be able to do that. Because that's unique.
And something that, like while we're on retreat, we're having a great time. Yesterday you sat down with Adrian to like implement the new NumPy sampler. And so yeah, like, well, one thing is it's just amazing to, as we're mostly remote, to then come together and like solve problems together. But yeah, maybe just like say sort of what was achieved there where we started and like how like just some, I don't know, implementational change like sort of led to a breakthrough in that system. Yeah,
so the story is there's many ways to sample from these models. There's many implementations of MCMC, and we're still in an interesting historical place in like Bayesian statistics where 10, 15 years ago, like MCMC was this thing that you'd have to wait for days for it to converge. Like it took a long time, and now computers are super fast and automatic differentiation and all these things. And so there's just so many different frameworks. There's a lot of different implementations. And so, yeah, Adrian from our group has built this awesome sampler called NumPy, and it is really fast. It has a beautiful UI, and when I first tried it out, I really wanted it to work for me, and it sort of worked, but I couldn't get it to sample on the GPU. And then there was like pressure for delivery, and then I went back to the sampler I was using before. And so here on the retreat, we have just had time to fix that. So we sat down yesterday, and I was like, Adrian, can you help me get this to work on the server? And he's like, yeah, just install it, it will work. And that of course did not happen, but for an hour of debugging, and we actually made it work, and it improved sampling times by like 5x. That was like a huge relief for me, but it was also like really good, because now we can sort of like ship this solution to the other engineers or the other people working on the project. And yeah, stuff like this is really awesome. It's like, it's amazing that we're a group of people where like we have different, very specific, powerful skills, and that when we meet we can sort of join these and and these really cool things happen, like a 5x speed up in sampling time. Like how great is that?
Yeah.
So, yeah.
Yeah, and especially like with these large scale models, and this is something that I think is a really interesting development that we're seeing, is that the type of models that have been built also by us just like 2 or 3 years ago compared to where they are now in terms of just like the scale, the sophistication, is just a different order of magnitude. And with that come like all these new challenges. Like these days, most of the models we sample are running on the GPU, just because that is the only thing that scales. And obviously for that, you need to be able to sample things on the GPU. And for that, we have the JAX backend. And then, yeah, like the most recent addition, the NumPy sampler, which like has just really pushing what's possible. Yeah, and Adrian's able to like sort of implemented that. So yeah, I'm really excited about not only like the solving these problems, but then also just being on that journey of like industrialization, I guess, of these methods and like really making them scale.
So yeah, I'm really excited for the future actually, because I think we're a good mix of people at this point with a diverse set of skills, and the motivation is really there. Like you really feel that people want to work on these projects that we have, want to contribute to the open source, and just since I started working with labs, a lot of things have already happened. So for me, it's I'm really excited to be like on the moving train. Like I really feel like that's the right place for me to be.
Well, thanks all for being on that train ride with us and for chatting with us today.
Thank you so much, Thomas.